Now, what is calibration plots? What is it? And why actually we need to build in our productionize the machine learning model? Why actually we need this concept? So let we have some data set, a D train. We have some data set, a D train. And on this data set, using this data set, we have built some model onto it. Let's call this model F. We have built a model F onto using this D train data set. Okay. Now another data set also we have the cross validation. Another data set is the cross validation data set. The cross validation data set. Now using these cross validation data sets, we have to predict that value. Suppose let the D cross validation data set is look like this type xi yi. Using this training data set, we have built the model F, and using this cross validation data set, we have cross validation data set xi yi. We have to find what will be its predicted value of these models. Means I am talking about this thing. Let's say means for age xi in D of cross validation for age xi, we have to predict what will be the output for this xi value. For this xi value, what will be the output by applying the model F on this data set, xi data set, and we have to predict what will be the value of the yi hat. Predicted value. This yi had actually the predicted value. Okay, what will be this? These things is simply it will be f of xi. These things, and this xi is belongs to D of cross validation. So now let's try to understand using this thing how will we plot this calibration plot. What is this significant? Let's try to understand these things through step by step. Okay. So first step that we have to do, we have to use the cross value. First, we have to build a table. So the first thing that we have to do, we have to build a table. First step that we have to do. How we'll build this table? So let's see. So if you think in the cross validation data set, we have in the cross validation data set, we have these two data xi and yi. To validate our model, we have used this data, cross validation data, and here yi is the actual output of this is value xi. Here y is the actual output, and using this xi onto our model, we have got the predicted output. So here actually here we have three types of data. We have the xi, yi hat, and yi. Okay? We have this data, and this yi hat is called the predicted output. Predicted output, and this yi is called the original output. Okay, and this is the data points. This is the data points or query point as you think. These three. Now first the table that we have to build, and actually just see here yi is 0, since we have considered in this whole section we have considered here two class classifications problem. So yi value here will be either 0 or 1. So the yi here it will be yi, it belongs to either 0 or 1. Okay. So first thing that we have to build the table. What will the table look like? A table look like this type. This type. Here it will here first here it will have xi, then here yi hat, then here we have yi. These three things we have in our data set. So okay, and here similarly let we have in our cross validation data we have n1 number of points. We have suppose let instead of using n1 let the number of data points in the d cross validation is equals to n. Let it will be n. So this is the n number of points they are have in this data set. Okay, first thing that we have to do this job. Now in second step, in second step we have to sort these tables in increasing order of this value of yi. The step that we have in this step. So in the second step we have to sort this table. We have to sort this table in increasing order of the value of using this value of y. Using this value of yi. And simple this predicted yi had is simple x of f of xi, and where xi is belongs to the cross validation. This is the simple thing. So here what will be the table look like this type of table. Here now we got this table will be look like this type. Three columns it have. First column is responsible for xi, second column is responsible for yi hat, and third column is responsible for first column is responsible for xi, yi hat, and y. That's the means, and here it is order it is sorted in increasing order using this value. This column is sorted by sorted in increasing order. These things are sorted in increasing order, this column. Okay, that means I'm talking about this thing. Y1, here it will be y1 hat is less than is equals to y2 hat is less than equals to y3 hat, like that. Like that means this kind. Since it is increasing order, we have to sort this table. That's the second step that we have to do. In third step, in third step, we have to break this whole table, sorted table, in chunks. So how much data points we have? N number of data points we have in our total cross validation data, and we have to break the whole table into small chunks. Okay, let's see how we'll doing. How will divide this whole thing? How will in small chunks? Suppose let okay. Suppose let this is our data set. So the thing that we have to do, we're going to do here, we have to break the whole table. In this table we have this type of data. We have here we have xi, here we have yi hat, here we have yi. These things, these three data we have. First we have to break the whole table into small chunks. So suppose let we have break into m chunks, m number of chunks. Suppose let it is the first chunk, small. Suppose let it is the first chunk 1, this is chunk 1, this is chunk 2, this is chunk 3, like that. It is chunk 4, like that, like this kind of chunk we have to. Suppose let it's responsible for the chunk one. This is chunk 2. Chunk 3. This is for chunk. Like that. In that manner, we have divided the whole table into like. Okay. So suppose let in each chunk there have m number of points. Suppose let in each chunk there have n number of points. Let in each chunk they have m points. Okay. Let. So suppose let here let. It will be better if we take some number. It will be better for better understanding. Let here m is equals to let. So in this chunk there have 100 points. In this chunk there have 100 points. In this chunk there have 100 points. Like that, man. So here we have taken here 4 chunks. So if each chunks taken 100 points, so total number of data points in the cross validation it will be 400. So here it will be better if we write this thing. Here we take 4 chunks. So the number data points in the cross validation set it will be m into n, m into number of chunks, hence number of chunks will be better if we take m into so we have taken here m equals to 100 into number of chunks equals to 4. So total we have 400 points in the cross validation data. So let thus it is the first x1 x2 like that. Here first 100 points. Here we have first 100 points. Similarly here it will have y1 hat, y2 hat like that, y100 hat, y1, y2 up to y100. Similarly in this chunk we get x101, it's 200 equal second chunk. Similarly here also. Like that. Like that in that way. Similarly in this chunk the value will be x301 to x400. Here it will be y hat 301 to y301. Like that. And this is the original value and this is the predicted value. Okay. This is the thing. The first thing in this step that we have to, after making this chunk, we have to find the in each chunk we have to find the average value. Okay. We have to find the average value of each chunk. Hence, we have to find the average value of yi hat in each chunk. I'm talking about now in each chunk yi hat. So this value will be 1 by m. Here we have m number of points and here I am taking here m is equals to 100 in m. I is equals to 1 to m. yi hat. Okay, this is the first in S chunk. In S chunk we have to calculate. In S chunk we have to calculate this value. Okay, average of yi hat and average of yi. So this value will be similarly 1 by m is equals to 1 to m yi. Okay, and this thing and this value is called the this value is called the y hat of inverse 1. Means it's these things are responsible for the first chunk. Similarly, this will be yi of 1. Don't be confused this one and this one. In upper script we have using notation this because it's upper script denoted the chunk, number of chunk. Its things are denoted the chunk number. Chunk number. These things is similarly the chunk number. Okay. Similarly for this time, for this chunk we can easily calculate it. So this for this chunks the predicted value will be y hat of 2 and y 2. Similarly here also we got y hat of 3 and y3. Similarly for this point also we got y4 hat 4 y4. Okay, this hat is responsible for average value of the average predicted value of the S chunk. And so we have here 4 chunks. So this kind of in the third step we have to doing this job. Now using this after building this, you have to build the calibration data. So what will be the calibration data? Let's see it. So decalibration. So this data structure is look like this type. Y hat I and yi. Okay, where I is how much chunks we have considered. In each chunks we have m points. So this I will responsible for 1 to number of chunks. These things are the number of chunks. So for this data set, these will be our actual data set. So for this value will be now this value actually what? This value is the simple average value of the predicted value. Average of the predicted value, average of the f of xi, and its xi is lie on the in S chunks, and these chunks is built after sorting the predicted value of this yi hat. Okay, this is the simple average value. Just see it. This is the simple average value. And now this value will be this value. This value will be think like a once this is the simple average of the original value, and the yi is just see it. Yi is it belongs to either 0 or 1. Okay, either 0 or 1. And if you take all the sums and averages, this value will be simple. This value will be if you think like it, this will be the total summations of yi's divided by number of points in the chunks m, number of data points in n. So these things will be since y and yi 0 or 1, these things will be either only responsible for 1, sum of 1, and by total number of points, this is the sense. So this value will be simply probability of yi is equals to 1 for a given data points xi. This value will be, since yi either 0 or 1, so this summations value will be how much data points are correct on this probability. Just see it. This average value actually give the probability value of what will be the probability of this, if you think like it. Probability of this will be for a given yq. This, if you just think like these things, if you like break these things like xi equals to 1 with given point y xi, the probability of the point xi. So means just think yourself. Just think yourself. What will be this probability? This will be the simple this thing. Okay, since y value y is carries either 0 or 1, simple this value will be this value. Okay, just think yourself. Just pause this video and think yourself, then you will got the point. Okay. Now, by using this point, using this calibration data point, if you plot this thing, these things are called the calibration plot. Fourth step. In third step, we have doing this thing. In fourth step, we have to plot the calibration plot. So, in the plot that we to build, these things are look like this type of two axes. In x-axis, we will use this value yi. These things will be the simple hat average value of the f of xi. These things, and in y-axis, we will use this value. In y-axis, we will use this yi. These things is simple average of the original value i's in s chunks, and these things is simple the probability of yi is equals to 1 for a given xi. We think like this thing. Okay, just think yourself through this formula, then you will got the point. Why I am writing this formula in this probability formula? Just take it as your exercise. Okay, these things. Now, if you plot this thing, if you plot these things, then you will look like this plot. This type of plot you will get this type of plot. Typically, it's depend to problem, situation to situations, but typically we got this type of problem. This type of plot we will got. This type of plot we will got. But it will be better, more accurate. If your model is more accurate, then our plot will be look like a 45-degree tangent line. It will be a straight line in a 45-degree manner. If everything is in okay, look like this type of plot will got if everything is okay. Okay. So suppose that means why this, if everything is okay, our model is perfect, everything is okay, then we got this type of plot. But in general and typically we will see that our plot is look like this type of. So why this thing happen? Suppose we have some point here, and corresponding this point, let for this point, and corresponding this point, they have the some value yi had 0.3, and this value is left. Since it is a 45 degree, this tangent at 45 degree, this value and this value is same, and this value is also 0.3. Since that means, suppose that this value is in some value, some chunk number. Let this point is responsible for y had some value k chunk, and y is value. That means what? That means for chunk 2, for chunk k, or for chunk k, for chunk k, y I had k, so yk. For chunk k, this value, this predicted value is equals to this one, this value. This is the chunk. This value means what? This value means the average of the average value of the predicted value for the chunk k, and this value is the probability of the class level L1 for a given query point xi. And so what will be its original class level? Probability of the original class level, and for a given query point xi. That's the value actually means. Means it is the simple average value of the original point. If everything is okay, our model predicted value, probability of the means average value of the predicted value and the average value of the original value, it will be same. And in this case, it is our perfect model. Okay, you can consider thing like that. But these things will not happen always. In the scenario, just see it. In this scenario, see it. The predicted value, but original point is look like here, somewhere here. If this thing happen, in this scenario, suppose that this original output is, it's the predicted output is 0.1, but the original one is giving us the 0.33. Predicted, we have predicted 0.1 and originally 0.2, means they have some differences. So because of these reasons, you can think like we have to data points, the calibrated data points that we got, we have to make some model. We have to make some model that will approximate the caliber, that will approximate the best plotted in our calibration data. You can think like these things like a regression model. Okay, I think you got the idea. And this regressions model will be our calibration model. Okay, I think you got the idea how we will create a calibration model onto our output of the model. Okay, using this data, using this simple data, calibration data, this simple calibration data. So I'm talking about this calibration data. Using this simple calibration data, we have to build a regression model. Yet we have only single type of data and single output. Using this simple data set, we have built a regression model. This regression model will be our calibration model. Okay, that's the simple thing we have to do. Okay, what so if you think it will better if you take some pictures from the Google, if you see it, then it will be more clear. Now let's try to understand these things through this example. Now let's try to understand these things through this example. The pictures that I am taking from the Google image. So if you search it, you can easily find this kind of image everywhere it is available. So in these things, see the first black dotted line. This black dotted line are shows that it is a perfect calibration. Calibrated means it's the 45-degree angle line. This angle is 45. If everything is perfect, if our model is perfectly calibrated, its accuracy is 100%, then we got this kind of calibration model. So now on this calibration data, means that this data in this side we have, the average of yi hat, and in this side we have average of yi. Sorry, average of yi. These things. Okay. This is the average value of the y I had, predicted value of the average, and it is the predicted. It is the it is the original value of the average, original value of the original output. If everything are perfectly calibrated, then we got this black dot line. Else, otherwise, you will got this type of. If we use the logistic model, if we use this, if we use the logistic model, then this blue color line, it give line some kind of accuracy 0.99. If you use the knife base, this will give the accuracy 0.118. If you use the knife base plus isotonic model, then it will give the accuracy like that. Here it will give like that, base plus sigma. So this kind of thing, it's depend on the problem to problem, situation to situation. So when we discuss the case study, then you will see these things in practical way. What will be the best fitted regression line? Means simple using this, actually end of the day use to build the calibration model. At the end of the day, we have to use the calibration data, and we have to make a regression model that will betterly fit this calibration data. Okay, so that's the thing that we have to make. It will be the perfect calibrated line, and somehow we have to make some model that will give the output this way. Okay, that's the thing that we have. This is called the actually calibration to find the accuracy. So at the end of the day, we have to calibration data d. We have the calibration data, and using this data we have to make some regression model. That's the job that we have to do in calibration. Okay, this is called the calibration model. I think you will understand the how the things are actually work internally. Okay, so after finalizing the this video, we can conclude in this video in like the end of the day. We have a query point. For this query point, we have to find the predicted value yq using the some model f, and using some model f, and this xq is coming from the cross validation data. This is coming from the d of cross validation data, and this f is built through the d train data. Okay, and this is the first step. And now after this step, we have to make on using this using this its predicted value, and using the yi we have to make some calibration model. We have to make some calibration model using this data from the xq. From here it is the yi. Here actually called the yq means yi hat. This is the original actual output. These things are called the predicted output. Predicted output. This calibration model will give us this kind of probability of these things that we got from these discussions. That's the simple structures from these discussions. Okay, I think from this discussion we will got the idea how we'll build the calibration thing, how will calibration model, and what is this actually calibration plot. You will got the idea what is this. From these discussions you got the idea. Okay, now in next video we'll see how to build these calibrations, and how to scaling this calibration type of thing. We'll see in these things next video. So I request you in this video, if you have any problem, please comment below. I will try to make it in a more easy way as I can, as possible.